Hey. So rather than type stuff out, I was thinking I found the old project, and I'm just gonna kind of um, go down one by one and try to remember what I was doing. But basically, idea is echo, right? So ignore all this other stuff I have in the scene right now. I guess I was doing some stuff. I don't know, but yeah. I purposefully added some noise and whatever to get it to look kind of more glitchy. But uh, this is how I did it, I guess. So I don't know how familiar you are with Niagara, but in Niagara, there's a lot of really good um, interfaces and functions that's given to us. So for example, one is just the skeletal mesh one, and we first just get the number of triangles there are on our skeleton, right? And then we spawn that many, and what you want to do, the main thing you want to do is understand this thing called um, barycentric coordinates, which is basically a way, find a photo, which is basically a way for the computer or our shader to kind of find where it is on a triangle. Because what we want to do is find, oops, the coordinate and locations of each of our triangles and then map our particles onto those positions. So this is how we do it. Unreal has a very, once again, a really nice um, function called get skinned triangle data. We just give it a skeletal mesh, and then you see here I'm giving it 0, 0, 1, 0, 1, 0, 1, 0, 0, which corresponds to three vertexes of a triangle that makes up a triangle on the mesh. So we go back here. I forgot what the winding order is, but it's essentially uh, one this point, and this point is what will return from this right here. And then we store that as a position. And then after that, we also want to sample the G buffer, and the G buffer is just basically this. It's all different parts of the frame that is captured prior to our final composite image, and we can get a lot of interesting data. In this case, we're getting base color, I think. Yeah, scene color. So we're just gonna take our triangle vertex positions that we got from here, and then get the color of that vertex at that position. Um, this you don't need to worry about. And then what we want to do now is just store these two bits of data into our dynamic material parameters, so we can unpack it in our material. So we see that we're doing that here. And then you don't even really need any of this stuff right now. That the curl noise and forces is just what's making fuck. It's just kind of making the thing go like nuts like that. But then down here is the next bit where you want to make the material that can read in all this data that we got from our shader. And it's also it's basically the reverse of what we just did. So as you can see here, these are our three bits of triangles, or that. And let's ignore all this for now. And then we basically want to, let's go down here. I don't know why I did it twice. But in parameter 1, I think we stored these in parameter 2 and 3. So, and here we can get that parameter. And then we're basically taking that position, we're getting our particle position, and then based on if it's vertex one or vertex two, we lerp that um, we lerp these positions. Uh, if you don't know anything, I don't. Once again, I'm not sure how much you know, but this is basically the same as doing like a component mask of just getting the x and y coordinates on this 2D texture, and that would fit these two up here, right? Well, because that will give us two of our three coordinates, two of our three vertexes on our triangle, and then that's the data we put in here. So we know that particle A is our original position. We want to lerp it to vertex 1 first, which is from here, and then we want to lerp it to vertex 2, and then we want to subtract that from our world position, which gives us an offset, and then that will give us a stretched version of this, of our mesh. Hopefully that makes sense. I feel like that didn't really make sense. But I mean, like I said, the idea is pretty simple, I think. And I have faith you can do it. But once again, I also haven't looked at this in a while. But yeah, hopefully that's helpful.